You're welcome to another section of Physics 191, Experimental Physics. And in this section, we'll be considering specific heat capacity of a good conductor using a metal block as an example of our good conductor, considering the specific heat capacity of a good conductor, and a metal block will be considered. And at the end of this unit, you should be able to set up the experiment to determine the specific heat capacity of a good conductor under the assumption that the calorimeter does not lose heat to the surroundings. Under that assumption that our calorimeter is not losing any heat to the surrounding, then you should be able to set up an experiment to determine specific heat capacity of a good conductor. Now, the method involved, the first thing is that you use a chemical balance or any other form of balance to determine the mass of the given metal block. The metal block you want to determine its specific capacity, determine its mass first, and you call that one M1. Then you weigh your stirrer and empty calorimeter together. You have a calorimeter, a stirrer is inside it, weigh it together with your balance also, call that one M2. Then fill the calorimeter 1/3 full with water, 1/3 of it full with water, and reweigh the stirrer and the calorimeter together with the water inside. Record that one as M3. Measure the temperature T1 of the water in the calorimeter, which normally should be the room temperature. Then you now heat the metal block tied to a cotton thread in the beaker of boiling water and record the temperature T2 of the boiling water. Metal block is inside the boiling water, then you record the temperature T2 of the boiling water. Then you quickly transfer the hot solid into the calorimeter. Quickly transfer that hot solid, that hot metal block into the calorimeter and stir thoroughly. Record the maximum temperature T3 attained by the water. You put your thermometer inside that water that is in the calorimeter. Then as you transfer the hot metal block into it, you will be seeing the rise in the thermometer. Then take note of the point where the thermometer is not showing increase again. That's your T3, the maximum temperature obtained. Then the calculation to obtain the specific capacity that we are actually talking about. According to the theory of conservation of heat energy, we have heat energy given out by the solid to be equals to heat energy absorbed by the calorimeter and its content plus the heat energy lost to the surroundings. Now, since we said that we want to assume that the calorimeter is not losing any heat to surroundings, so the second term in the right hand of that equation will be neglected. So if we neglect the second term in that right hand of the equation, definitely you have equation 1 left, which is M1 S into bracket T2 minus T3. Earlier I have explained what M1 is, what T2 is, what T3 is, and all of that. What I need to mention here is that our S is the specific capacity of the metal block that you want to determine. And of course, what we use W to represent here is the weight, the mass of the calorimeter multiplied by the specific capacity of the material of the calorimeter. That's our W here. And look at this expression, W equals to M2 times 400, like I said, 400 joule per kilogram per Kelvin. That 400 joule per kilogram per Kelvin is the specific capacity of the material with which our calorimeter is produced. Then you can calculate your specific capacity of the. In this unit, you've been able to learn how to set up the experiment to determine the specific capacity of a good conductor under the assumption that the calorimeter does not lose heat to the surroundings. Once you take all your measurements correctly, as I've explained, your M1, your M2, your M3, your T1, your T2, definitely to get the specific capacity of the metal block that you want will be very, very easy. That is the end of this unit. Thank you.